recording this lesson, they will be asking you about like, hey, how much of this particular ion is in solution, okay? Or like this question here is saying, how many moles of solid barium nitrate do I have to add to the solution, right? They give us 300 milliliters of 0.2 molar iron nitrate to increase the nitrate ions concentration to 1 molar, all right? So they're basically saying like, hey, we have this solution that's got nitrate in it already. How much more do we need to add to make the concentration of nitrate this, okay? So this is not solution stoichiometry, this first question, okay? But we need to be able to use like some mole ratios and things like that, and our understanding of what concentration is, right? What molarity is, right? In order to figure this out, okay? So let's walk through this here. So a couple things that are important about this question, right? We're putting in solid barium nitrate to this solution here of iron nitrate, okay? And ultimately, we want to get to a nitrate ion concentration of 1 molar. And a real important part is we're assuming that the volume of the solution remains constant, right? That's really important. So when we put these ions in solution, when we put these nitrate compounds in solution, what do we know about nitrates? They're always soluble, right? They're always soluble, so they always break up into their ions in solution, okay? So when I put in 1 barium nitrate into solution, what does it break up into? How many nitrates are in solution? We get 2 nitrates floating around in solution, right? Okay. Everybody see that, where that's coming from? All right, great. So what's the first thing we need to do here? What do you guys think the first thing is we should do? Yeah, well, this is for stoichiometry, you always would. This is not a stoichiometry type problem. Okay, so but on the backside when we do a classic solution stoic, we will. Yeah, we don't have a reaction going on here. We're just looking for the concentration of ions in solution. Oh, and M1V1 equals M2V2. I would say no, because our volume stays constant. There's no change in volume. We're not diluting the solution or anything like that, right? So we want to get a solution that is 1 molar nitrate ions, right? And currently we have a solution that's 300 milliliters of 0.2 molar iron nitrate.
Would you do like 2.0 equals M, given all the moles over 30, not 30.
Well, yeah, I mean, you're getting there with what we want to do. Like, we need to find the current concentration of nitrate ions in solution. Right, that's the first thing we need to do here. That's our first step. Okay, that's what we got to figure out first. Because if because we have to figure out how many more nitrate ions we need to add to get to 1 molar, right? We're not there yet, so we need to figure out where we're started, right? Okay. So in order to do that, I'm gonna do this. I'm not gonna set it up like you want to set it up. I'm gonna set it up like dimensional analysis, right? Okay, factor label method. All right, like we always do it here. Okay, so we're gonna start with. No, I'm not. We're going to start with 0.3 liters, okay? And we're going to use our concentration here to convert into moles, right? So 0.20 moles of iron nitrate in 1 liter, right? And what we're interested in is the concentration of nitrate, right? So what do we need to know how many moles of nitrate are in solution. So what do I put in my next conversion here? Every 1 mole of iron nitrate, very good. There we go. So liters cancel, moles cancel, and you're left with third. Do you happen to do that yet, or I heard you punch away on your calculator? 0.3 times 0.2 times 3. Okay, so I got 0.18 moles of NO3 minus. So we know the moles of nitrate in solution. Okay. So now the next thing we want to do, so the next thing we want to do is we need to find out how much more nitrate we need to add. Okay, and so this is where I'm gonna. What do we know? Like we know it's 1 molar nitrate. That's right. So if we break that down, that means we have 1 mole of nitrate for every 1 liter, right? So the volume of our solution currently right now. Well, that's 0. Oh yeah, it is. Yeah, 0.3 liters. Okay, so how many moles of nitrate do we need to have in there to make it equal to 1? What? That's how much we need, right? How much more do we have to add? How do we figure out how much we need to add? What do you want to do, Claire? Yeah, so we're going to take the moles that we have, minus 0.18, give us 0.1 moles of nitrate that we're going to need. Well, that we're going to need to add, right? So those are how many moles we need to add of nitrate. Okay, but we just don't have moles of nitrate lying around, do we? What are we adding here? How are we adding in our moles of nitrate? Yeah, we're adding barium nitrate. So that's what we need to figure out. So we have 0.12 moles of nitrate that we need to add. Well, how many moles of nitrate are in every 1 mole of barium nitrate? You gotta look at the formula. Yeah, there's 2 moles of nitrate ions for every 1 mole of barium nitrate. So 12 divided by 2 is 0.06 moles. Okay. So you've got to be able to make some mole ratios of ions out of formulas, right? Out of a chemical formula, right? You're going to be asked to do that on your homework and stuff like that. So that's not solution Stoich. The back side of this page is solution Stoich. Okay, so let's do that. Let's do the back side here. This is solution stoichiometry here. Okay. So if we're dealing with stoichiometry, I mean, you can read it right here. A 25 milliliter solution of, what is that? H2PO4. Phosphoric acid, yep. Okay. It is completely neutralized by 28 milliliters of 1.9 molar KOH, which is potassium hydroxide. Okay, just practicing for our nomenclature quiz tomorrow. All right. What's the molarity of H3PO4? So molarity breaks down to what? Moles over liters, right? Well, what's the volume of our H3PO4 solution? 0.025 liters. Okay. And we don't know the moles of H3PO4. Right? Because if we did, then we could find the concentration. Right? We would know molarity, but we don't. Okay. So that's what we ultimately need to find. We need to find moles of phosphoric acid so we can plug it into there, figure out what our molarity is of that solution. Okay. So we need to write a balanced equation. Yep.
Wait, no. Did you do M1 or MB equals MB?
No. I'll show you in 1 second after we write this balanced equation. Yeah. Yes, it is the ratio. Okay. So when you do this, you would like to think you could do M1V1 equals M2V2, but the ratio is not 1 to 1. So, yeah. Okay, so it's 3 to 1. So, because in every single one of our reactions here, we want to get into moles, okay, mole ratio, get out of moles if necessary, okay, if we have to convert into something outside of moles. All right, so, well, what do we start with? We have to start with the substance that we know the most about, okay? So we're starting off with the KOH info. So we've got 0.028 liters, and we need to get into moles. So we're going to use that molarity, okay? 1.9 moles of KOH for every 1 liter. And now what do I do? Next step. So if we're in moles, what's the next step for stoichiometry? Always mole ratio. Okay, so what's the mole ratio? How should I plug in the mole ratio here? What is it? 3 moles of KOH on the bottom, so then that cancels. 1 mole of phosphoric acid on the top. All our units cancel out, so we have moles of H3PO4. So 0.028 times 1.9 divided by 3. So we get 0.0177 moles of phosphoric acid. They're asking for the molarity of phosphoric acid, though. So what do? Right, we're going to plug it in right there, right? Because that's why we did this whole operation. Right, so 0.0177 moles divided by 5 liters. We get 0.709 molar phosphoric acid. Beautiful. Okay. Get into moles, mole ratio. Maybe get out of moles if we have to. All right, next question. Are there any questions about that one? Okay, so that's one style. Another type of question they might ask is how many liters of 0.33 molar HCl will neutralize 25 milliliters of 3 molar barium hydroxide? Okay, so this one sounds like get into moles, mole ratio, get out of moles, because we're going to go back to liters. Okay, so, but what's the first thing we have to do before we do this? Balanced equation. Got to write a balanced equation. HCl plus barium hydroxide So we get, right, barium chloride and water. We need 2 hydrochloric acids, right, for barium hydroxide. We need, that would produce waters. Okay. All right, so what do we start with? We start with the substance that they give us the most information about. Okay, that's why we started with that one. So we start with 0.025 liters because we have to get into moles. We use the molarity as a conversion factor. So we have 3 moles of barium hydroxide for every 1 liter. Correct. Moles per liter. That's all right. What's the mole ratio here? Where's the mole ratio from? Anna?
1 mole barium hydroxide and 2 moles of.
Great. Mole barium hydroxide. Moles HCl. Very good. So we got to get back out of moles. So what do we use to do that? The concentration of HCl that was given to us. So we're trying to get back into a volume, which is going to be liters to the top. So we have 0.33 moles of HCl. So in every 1 liter, there are 0.33 moles of HCl. So notice all the units cancel out, liters cancel, moles of barium hydroxide cancel, moles of hydrochloric cancel, so we're left with liters. So you can flip that molarity around however you need to use it. Okay? 5 times 3. 2, 3. We get 0.455 liters. That's liters of HCl. Hydrochloric. Okay, good. All right, well, with stoichiometry, what question is always there? I will end up dealing with limiting reactants. Yeah, we got a little limiting reactant problem here. And our next question is limiting reactant problem. How do I know it is a limiting reactant problem? Right, exactly. They give you everything you need to know about Ki, and they give you everything you need to know about lead to know how many moles of that substance you have, okay? So that's the key sign that you're getting a limiting reactant type of problem, okay? They give you all the info you need to know about your reactants, okay? So first thing, no matter what, we got to have a balanced equation, right? And lead nitrate. So potassium iodide and lead nitrate combine to form, what are my products here? Potassium nitrate, okay, good. And lead iodide, good. All right, so you guys, solubility rules, which ones are precipitate? PBI2. Hey, even if you didn't know that, they let us know like how much PBI2 will precipitate. They let you know, right? By reading the problem, they tell you what should precipitate. All right. Is it balanced? Or what is it? What do I need to do to balance it? Okay, very good. Okay, so, and they just want to know how much PBI2 will precipitate. So, do I even care about finding the limiting reactant or anything? No, not really, right? I'm going to go straight towards moles of PBI. okay, for both reactants. Because they just want to know how much we're going to make. So whichever one produces the least is how much we make, right? Okay, so we're going to set two problems up, and we're only going to keep it to 2 steps. We don't need to go all the way to grams because they don't ask us for grams, right? So we can just do these with 2 steps and just go to moles, all right? So I'm going to do the Ki first. All right, so we've got 0.0325 liters, and these are going to be 2 steps. We're going to moles of lead iodide. So let's see, we got 3.5 moles of Ki for every 1 liter. And there's 1 mole of lead iodide for every 2 moles of Ki. All right, so we've got 0.0325 times 3.5 divided by 2. So I ended up with 0.0569 moles, it looks like. Okay, so we have to do this for the other reactant too, lead nitrate. Okay, so we got 0.065 liters. And we set it up the same way. We're solving for moles of lead iodide again to see which one produces the least amount. So we have 0.85 moles of lead nitrate for 1 liter. And the mole ratio here is 1:1, right? So it's for every 1 mole of lead nitrate, I can make 1 mole of lead iodide. So 0.065 times 0.85, end up with 0.055, and that's 25, so that's 53. So 0.0553 is less than 0.0569, right? Okay, so that's how much we can make. That's the least amount we can make. So that's as much as we can make, right? Well, those are your classic Stoich sort of problems, right? You guys don't really need to worry about doing the pre-lab until Monday, but I mean, you could start doing the pre-lab now that you've done solution stoichiometry, okay, if you wanted to. You could start working on your online homework as well right now, so we got time to do that, okay? We got 21 minutes. Let's make the most of it, okay? Let's knock something out here, all right? Yeah.
Number 6, I'm a little unsure where to start. Because if you just do moles over liters, 82.8 over 0.66 is like 130 molarity, and that doesn't work.
It's asking for acetate ions.
Isn't there one no, there's one there's 2 acetates for every 1. See, but still, that would double whatever answer you got. So if I got like 3 calcium acetates, I get 6 acetate.
Okay.
But I'm a little unsure because even ignoring
Find the moles of acetate ions, divide by your volume of your solution in liters.
so 82.8 is the moles of calcium acetate divided by 0.6168.
No. We want concentration of acetate ions. You're doing the concentration. You're finding the molarity of calcium acetate. I just want the concentration of acetate ions.
So I get whatever moles of that I have, multiply it by 2 to get the amount of acetate ions.
So you have moles of this. You have 80 what?
2.8. There's 2, so multiply that by
that, right?
And then I take whatever that is, and I divide by 0.6168.
Yeah, whatever the lead, whatever the lead is.
What doesn't make sense to me is that would give me having a molarity of something like 200.
Who cares?
Can you actually have a
Don't
solution?
care. Don't care.
Can you actually do that though? Have a
Why not?
200 molarity solution?
Maybe. It doesn't matter. Don't care if it. Yeah, like
No, because like I always, whenever I get an answer, I always check. Okay, does it make sense?
right.
But the most I've ever heard of is like 14.
It's goofy, but
Crazy.
yes, it's goofy, but yeah.
Okay, would I be able to
21 minutes. Well, 20 minutes.
would I be able to take the double replacement quiz?
Sure. Yes.
Quiz on Monday too. Like March.
Yes. Nomenclature quiz
Tomorrow and Monday.
on Monday. Tomorrow and Monday.
For the double replacement quiz, the ones that are soluble, you basically like cross out, right? They're spectator ions.
If there's spectator ions, scratch out. You. No, we don't need it right now. You can work on it if you want to, but you'll get it tomorrow. You'll have to work on it. Yeah. I don't know. Miss Marks put it down. I'm not sure. Oh, it is. I mean, you could do it now like you've done this. When it's talking about dissolution dissolving in water, all you care about is it breaks up into its ions. You don't need a reaction, right? You just need to know how many moles of steam. You know what I'm saying? Oh my gosh. 71 degrees out right now. 71 degrees outside right now.
Serious?
Wow, I'm gonna have to. I want to put up those Christmas lights today. Get out there now, or it gets cold later. Yeah, what's up? Yep.
So here's what I've been doing. Tell me what I've been doing wrong. Number 8.
Okay. So you got grams of NaO of hydroxide. It's dissolved into that much sodium hydroxide. The solution is then poured into 2.375 gallons of water.
And then what's the final?
You may assume that the 2 volumes can be added. What's the concentration? So first thing you got to do is figure out how many moles of sodium hydroxide you have.
That's what I did. And so I did 0.25 molar NaOH is 0.25 moles for every 1 liter. And I multiplied that by 0.647 milliliters to get it was 0.1977 moles.
Okay, great.
So that's how many moles you have just already laying around.
And then how many more moles did you add?
And then you added 0.16925. That might be where I screwed up. NaOH is 39. It's 40. It's
Yeah, I might as well do
39.9.
40 here.
I'm just going to do 40.
Yep.
It was 7.91 divided by 40. Or not 40. Oh, I'm sorry. You have that's 0.1977 gram
Plus,
plus the point plus 0.16925 0.6925 you already had,
Right. So add those two together.
and you get a magical. Already have like around 0.36695 moles,
Okay.
and then you need to figure out how much total water you have,
Right.
which is 2.37 gallons of water, which, let me see, 2.37 gallons, 2 liters. I don't remember the correct conversion off the top of my head. It's this many liters.
Okay.
You add 0.647 to that, because that's what you had originally. Plus 0.647.
Okay.
You get 9.618.
Okay.
You divide those two. You get divided by 9.618. And you get 0.038.
Okay.
I plug that in, and it's not right.
Well, okay, wait.
I already have that answer anyway, so
Well, why did? All right. So, what have you tried?
I've tried rounding. I don't know why I did that.
I don't know either. So type in 0.0381524.
2, 4. Incorrect. And I don't know where I'm making an error. So I'm somehow making an error multiplying point
So
2.
we'll go back to the thing.
Sorry. Oh, that's what I did.
When you're writing. Is that what happened?
Maybe. Tell no one of this. It's never happened.
Oh my gosh, I can't believe, like, how do you keep straight what you're doing right now?
I can keep this straight. I can't keep my own handwriting straight.
Okay.
This divided by that. Divided by
618.
9.61846. Well, now I feel really dumb. Wait a minute. But that still would round to 0.04.
No. You got to put in all the digits, remember? So paste that.
Well, let me just copy and paste. I really hope it does. It did. Oh, what it gave me that. Gave me everything I didn't want. Here. This is why I'm gonna cry. Okay. But then, hold on. Because I know this. If I had rounded this to 0.0374, it would have accepted it.
Probably because it gives you a plus or minus 1%.
No, it lets you round. Because in other of these I've rounded and it takes it. I could have done 0.0.
Because you're within the plus or minus, like, given.
No, because if I did,
You're allowed a particular amount of uncertainty.
here's what I know. If I did 0.03734, that would be accepted.
Because you're within, that's what I'm telling you.
But
What?
if I did 0.0373, it would count that as incorrect because it's rounded incorrectly.
No, it doesn't have.
Really? I've never had that problem before.
I have.
Really?
Yeah.
Okay, that's interesting.
All right. Whatever, I got the right answer, and it's not like the other ones where it takes off like minus 20%.
I'm just telling you, no rounding on that.
What time do we get out? What am I asking you? It's right there.
Thank you. I was going to direct you there anyway.
What am I asking? Find out myself.
That's right. That's what I'm saying.
Oh, are you? You're all 11?
Mr. Sepple, I was trying to figure out what. It says the sample.
You gotta add. So you gotta find the total moles of sodium hydroxide. No, the total, because you also added 7.02 grams of sodium hydroxide.
Okay, and then you,
divide by the total volume.
which is the N volume for the.
So the gallons plus the
plus the
milliliters, which you gotta get them both in the same unit.
Okay.
Okay.
I kept thinking, I was trying to like catch up. I kept thinking setting this up right, but I can't get the right answer.
Because there's 2 moles of zinc chloride for every 1 mole of zinc you put in solution.
Okay.
Where's your work for that one?
Yeah, I mean, I did that wrong, but like, what is right here?
So set it up. You guys love to just set up formulas. Do the factor label method. Line up the units, right? So like 1.75 liters times, in parentheses, you'd have 1.0 times 10 to the minus 3 moles of zinc chloride for every 1 liter. And then you've got to do the multiplication of 2 moles of Cl ions.
So that, and
And then there's 2 moles of Cl minus of chloride ions for every 1 mole of zinc chloride. There you go. Then you're in moles of chlorine. So I'm saying do it like that.
Okay.
Okay? Mm-hmm.
That's the same answer, it was still wrong. I'm gonna give the same answer, but I got another answer, it was still
so Mr. Simplified, I can't find it. 0.5. I say my 0.5 times 10 to the minus 5.
Oh, I'm not gonna be running it. 6 days.
Yeah.
I go back. He just goes over his. At least he goes over something.
I'm a stock clerk. Wait, were we supposed to do Rachel's money? No, right?
What should we study for the quiz tomorrow?
It's just neat. I mean, there's not really much to study except for like your polyatomic ions. What?
I literally have this tomorrow. I mean, I know so much.
That ain't gonna be enough.
Everyone who, like, there's so many people going into, like,
So wait.
and then psychology.
Mr. Sickle,
Like,
is molarity actually counted as an actual thing?
Solution is dissolved in water. Like if I have pure undiluted HCl, what would the molarity of that be? Just whatever molar is.
Right, molar at that point it's a solid, right?
Yeah.
Molarity is concentration. Like so, one thing dissolved in another.
So you can't really have that.
Like water, right?
Or
See y'all later.
Have a good night.
Ruben,
If
you
you want
too.
to solve this problem, you gotta graph it.
What's up?
you deal with the noise, stupid.
Oh, I just, whatever, it's fine.
If I was a teacher, I'd be like,
He's
no, just like any teacher, like any student.
well, there's different forms and levels. Like he is not annoying in a bad way to me.
I think he is.
Well, he's annoying other students, and I get why that's the case. And I try. That's why I tell him some days, I'm like, I'm not calling on you, or whatever. You know what I'm saying?
Yeah.
But like, there are people that are annoying to me that are
Patient.
that are very mean, and that I don't have patience with. He's just being him. He's not being mean. He's not being. You know what I mean? I get why people find him, would get annoying or whatever. But me, I think it is. Yeah.
The cons are back and the cons are down. We have to quiz.
Yeah. I heard it doesn't count.
Okay.
So like me. I don't know if you guys.
All I remember is like the eights and the ice, man, and then I remember acetate. That's better. Oh, and hydros. Oh, you read that?
Yeah.
The more three that are like each mini quiz, basically. Apparently she heard that doesn't count. I'm really
People
bad.
told me that it doesn't count, but I don't.
What doesn't count? I wouldn't.
It'll be up to you.
Yeah.
I'm gonna go ahead and say no.
Then, yeah. What if it's just that? It's just that, like, Matt, are you enjoying that textbook so far?
That's so many people. Everyone
Yesterday, right? And I quit today.
There's a quiz on
Naming, I really need a freaking I appreciate it.
I literally offered to that for you, but I told my, what she but I was
We don't need y'all for your table.
Okay, hold on, let me go talk to your
Oh, you got juice and juice? That's so water. That was water. I'm scared. Watermelon.
Strawberry watermelon.
I think.
He's trying to be like LOL. Come on. There we go. I did it before you.
the one with the blonde hair was talking about. Why are we getting creative too?
No, it's like,
If you have test corrections, turn those in. If you have your lab, turn that in. Tomorrow, preferably. All right, sit down, please. Let's get this going. Let's go. I cannot stand Twizzlers. So gross.
They're not that good.
It's mostly the texture. Of what?
No, yeah, Twizzlers are nasty.
Nasty, man. Those are fine.
They don't even taste like.
They don't.
They're not that great. Twizzlers are terrible.
Not good. All right, so we're gonna kind of we want to get through today so that we have some things to work on. So if we get through today quick enough, we'll have about 20 minutes or so to work on a few things. Parsons, right? That's who we're missing, right? Okay. Oh. Yeah, you need a calculator on your periodic table out to get this going. Okay. Oh my gosh.